This video is about the limiting value of a sequence. What this means is, as a sequence continues for an infinite number of terms, does the sequence converge to a value? Does it get closer and closer to one value, or does it actually diverge and not have a limiting value at all? So let me explain this with a couple of examples. Let's first off start with a nice simple linear sequence that you're used to seeing in your regular GCSE maths. We've got the sequence 2n plus 3. So its first term is 5, second term 7, third term 9, fourth term 11, and so on. This sequence, we can see it's going up in 2s each time. If I kept going, so the next term would be 15 and so on. If I kept doing this, it's just going to keep on going up and up and up and up. There is no upper limit to this sequence. If I wrote down the 100th number or the 1000th number or the 1,000,000th number, the numbers just keep getting bigger and bigger and bigger. There is no limiting value to this sequence. But the second sequence underneath there, the sequence of 1 over n, you can see the first term is 1 because 1 divided by 1 is 1. The second term is a half because 1 divided by 2 is a half. The third term is a third. 1 divided by 3 is a third, and so on. This sequence, we can see the terms are getting smaller each time. We've got 1, then 1 half, then 1/3, then 1/4, then 1/5. The 10th term in the sequence would be 1/10. The 100th term in the sequence would be 1 over 100. The 1,000,000th term in this sequence would be 1 over 1,000,000. So as n gets bigger, as n tends towards infinity, as it gets bigger and bigger and bigger and bigger, the 1 over n gets smaller and smaller and smaller. It would become 1 over 1,000,000, then 1 over 2,000,000, 1 over 3,000,000, 1 over 10,000,000. It gets closer and closer and closer to 0. So this sequence does have a limiting value. It would tend towards 0. It won't ever actually become 0 because I can't do 1 divided by a number and get 0. But it will get closer and closer and closer to 0. So 0 is the limiting value of this sequence. So that's what we mean by a limiting value. Let's have a look at an example using this then. So the nth term of a sequence is n plus 1 over 3n minus 1. Part A says to write down the first 3 terms of this sequence. So nice and simply, first of all, when n is 1, that's the first term of the sequence, I'd have 1 plus 1 over 3 times 1 minus 1. So 2 over 2 is the same thing as 1. So when I substitute 1 in here and here, I just get 1 as my answer. Second term, when n is 2. If I substitute 2 here and 2 here, I get 3 over 5 or 3/5. For the third term, when n is 3, substituting 3 in here and here, I get 4 over 8, or 1/2. So the first 3 numbers in this sequence are 1, 3 over 5, 3/5, and 1/2. Part B. What position is the term 0.375 in this sequence? So I know 0.375 is in the sequence, but which term would that be? What's the n value when the sequence is equal to 0.375? So if I take my nth term and make that equal to 0.375, I can then hopefully solve this to work out what n will be. So I'm going to multiply both sides by the 3n minus 1 I'm then going to expand those brackets. So I'll get 0.375 times 3n is going to be equal to 1.125n. The 0.375 times minus 1 is minus 0.375. Now, moving the n's all onto one side and moving the numbers onto the other. So I've got 1 plus 0.375 is 1.375. And then I've got the 1.125n, take away n, which is this. And then if I divide both sides by the 0.125, I find that n is 11. So the 0.375 would be the 11th term in the sequence. Part C, I need to show that 0.42 is not a term in the sequence. So I'm going to use a similar method to what I've just done, where I showed that 0.375 was the 11th term. So I'm going to make my nth term equal to 0.42. Again, I will solve this equation. So 0.42 times 3n minus 1. Multiplying that out then, I'll get 1.26n minus 0.42. So 1.42 is equal to 0.26n. Divide both sides by the 0.26. And I find that n would have to be equal to 5.46 blah, blah, blah. So the point is that that is not a whole number. And n is the position. It's the position of the number. So I'm saying that 0.42 is the 5.46th term. That doesn't make any sense. N has to be a whole number. So which is not an integer. Therefore, 0.42 is not in the sequence. Has to be a whole number, like it was a moment ago when we saw that 0.375 was the 11th number. And finally, part D, we need to write down the limiting value of the sequence as n tends towards infinity. So let me just take this sequence. What happens to this as n tends towards infinity? Well, as the number on the top here gets bigger and bigger and bigger, so does the number on the bottom here. So it's a little bit difficult for me to say exactly what's going to happen the way that this is written at the moment. But there's a trick I can use. What I'm going to do is I'm going to divide everything on the top by n and everything on the bottom by n. So just looking at the numerator then, just looking at that top term, I had n plus 1, but I've just divided that by n. So the n divided by n is 1 plus the 1 divided by n is 1 over m. Similarly on the bottom, the 3n divided by n is 3. And then the 1 divided by n is 1 over n. Now this is going to be much more useful because I can say now that as n tends towards infinity, well, I know that 1 over n is going to tend towards 0. Because 1 divided by a huge number is going to tend towards 0. So 1 over n on the numerator is going to tend towards 0. 1 over n on the denominator is going to tend towards 0. So this whole sequence then is going to tend towards, so as n tends towards infinity, this is going to tend towards 1/3. Because as I say, the 1 over n's are going to tend towards 0 and just leave me with the 1 on the top and the 3 on the bottom. So what I'm saying here then is this sequence, we started with 1, we then had 3/5, we then had 1/2. We saw that the 11th term was 0.375. If I kept going with this sequence forever, it's going to get closer and closer and closer to 1/3. It's never going to actually become 1/3 because this 1 divided by n will never actually equal 0, but it's going to get closer and closer and closer to 1/3. That is the limiting value of this sequence. So the trick for these questions, to find a limiting value, you want to divide the top and the bottom by n so that you can let n tend towards infinity, and then you will have a fraction that makes it nice and simple.